All right, this is where we left off. If you have not finished writing this in, make sure you get it in. The one thing I want to go in and add something to this real quick. So down here in the third bullet, it says, in this case, the units would be cubic centimeters. Now, the point that I want to make about the cubic centimeters is this is normally for solid objects. Okay, normally. Now, the word normally, does that mean it is always for solid objects? No, okay? There are certain things we can use cubic centimeters for, but most of the time it's going to be, and I apologize about that for, I don't know what I was writing there. But it's possible we can use it. So if I take this box up here, and I ask you to calculate the volume of this box, what would you do? Measure it all the way around, right? What would you use? What unit would you use? Don't you dare say inches, okay? Centimeters, all right? So we'd use this centimeters. How many times would you at least have to move this thing right here? At least 3 times, right? We'd have to go across, we'd have to go up and down, and we would have to do the depth, if you would, to be able to calculate it. So the example they give us is if we have a box 2 centimeters by 2 centimeters by 5 centimeters, we would have a volume of 30 what? Cubic centimeters. It's important that you understand that cubic part of it because, again, it's a cubed value. Now, you can say centimeters cubed. That's perfectly acceptable. Absolutely. Okay. But the part is there's got to be a cube somewhere on it. Now, next part. The base units for volume is also considered to be the liter. But if we're dealing with the liter, what are we more than likely going to be working with? Now, I like to throw this in there. Is it just liquid? No, what else could we also be measuring the amount of? Gas. Water is a liquid. Okay. So, liquids or gases. Now, again, I know sometimes gases are kind of strange to think about. How do you calculate how much gas there is? Well, if you take a balloon and blow into it, what's inside the balloon? The gas. Does that balloon have a specific volume? Yes. Okay, so you can do it that way as well. Now, obviously, you wouldn't want to do gas in a graduated cylinder, but you could if, I don't know why you would or what the purpose would be, but it's possible. But again, that's what we would use. Now, if we are doing a liquid water, what is the point at which we measure the liquid called within the graduated cylinder? Very good. That's the next slide. So, whenever we have liquid in a graduated cylinder, we measure it from the point called the meniscus. The meniscus. Make sure you get this in. Okay. The meniscus. Meniscus. And we've talked about this, but what property is it that makes the water stick to the sides of the graduated cylinder to give it that little bow effect? There's a property of water. Cohesion. Very good. But remember, cohesive things make two unlike things stick. And are glass and water alike? No, they're different. Okay, yes, sir. It happens to be the same name. Okay. Liquid volume. Now, if you like to highlight things, this is where a highlighter is going to come in very handy. If you need to star things, circle things, star, circle, highlight, underline, this is going to be very important. That part down there at the bottom. When the people were first developing the metric system, they did something very, very, very insightful. That's going to allow us to transition between units very seamlessly and smoothly. Okay. In all of science, what do you think probably the number one most used stuff is? Substance. Water. Okay. Water is probably the most used thing on the face of the planet as far as its use in any type of experiment. Now, it doesn't mean you're always going to use it, but it shows up quite often. What they did is they said, all right, let's make our standard water. And for their standard, when they first developed the measurements, they said, we're going to take 1 gram of water, and we're going to make it exactly 1 milliliter. And we're going to take 1 milliliter of water, and we're going to make it exactly 1 cubic centimeter. So again, I'm not a world's greatest artist, but I'm going to just accept it for just a second. That's cube enough, right? Okay. So what they're saying, could make the lines touch, make it a little better. So what they said, my cubes always look awkward. What they said is that this is 1 cubic centimeter. So this is what by what by what? Okay, so it's 1 centimeter wide by 1 centimeter deep by 1 centimeter tall. Okay, and they said if this is water, it's also equivalent to what? 1 milliliter. And if you put that cube of water on a scale, how much did it weigh? It weighed 1 gram. Do you see how that could be very beneficial to us? Yes, it is very, very, very beneficial to us. And we'll talk about that in just a second. Go ahead. Okay. And again, this is a standard that they used. Then the follow-up question that I have to ask at this point, what if they changed it to glycerin? Are those 3 numbers still the exact same? No, this is only referring to what? Water. Yes. We're going to get to that in a second. The next thing I need to ask here is, is this referring to specifically just deionized water? No. Because I get it. Deionized water and tap water are totally different. If it's tap water, just assume the same thing is true. It may not be perfect, it may not be precise, but just accept it for what it is. Okay? Alright, so again, that's something important. Make sure you highlight that. Water displacement. So if you need to know the volume of a dead body, just kidding, that was a joke. Okay? So if you need to know the volume of any object that is irregular or not perfectly cubed, you can calculate that volume by doing something called water displacement. Water displacement. So if you have a rock and you want to know how much volume that rock takes up, and it's really weirdly shaped, can you use a ruler? No, it's not going to make any sense. It's not going to help you. Okay? So what water displacement is you take a graduated cylinder and you fill it up to a certain amount. You take that rock and you toss it in there. How would you then know the volume that rock occupies? Okay, it's the difference. That's the key. Is in the past, I've had some students mess this up. Here's what they say. Do you see over here on the left-hand side of picture number 1, how much water is in that graduated cylinder currently? 7 milliliters. When you put the rock in, what did it go up to? 9. Some people in the past have taken this question and said the volume of that rock is 9 millimeters. 9 milliliters. Why is that incorrect? Okay. Was there already 7 in there? Yes, you have to take the difference of the 2. Now this is just easy, simple math, and it's not always going to be that perfect, but you need to take the difference of the 2, not just what you have. So do me a favor, somewhere in this general range in your notes, please write final minus initial. Is that too many eyes? No, that's right. Okay. Final minus initial. So to calculate the volume of that rock, would you do 7 minus 9 or 9 minus 7? Okay, if you did it the other way, what would you get? A negative number. Can you have a negative volume? Not on this planet. Okay, your volume can go down, but you can't have a negative volume. Okay, so it's not a black hole. Alright, so again, we've already talked about this. This is very important. 1 cubic centimeter of water is 1 milliliter of water, which is 1 gram. Please do not scream this out loud. Let me call on somebody. So my question is, Caleb, what is the mass of 50 milliliters of water? Thank you, sir. Very good. 50 grams. This was a little bit more challenging. Okay? Think about this one. Nobody yell it out. I'm going to let you think about this one first. What is the mass of 1 liter of water? Aubrey? I like that. Yes, but there was something else, Amari. Okay. Would you say that a little bit louder, Aubrey? 1 kiloliter, kilogram. Yeah, 1 kilogram. Okay. Now, there's another way to say it. Instead of saying 1 kilogram, what could you have said? 1,000 grams. And here's why. If 1 liter is how many milliliters? 1,000. So 1 liter is 1,000 milliliters. So its mass would be 1,000 grams or 1 kilogram. Okay, I know that this is weird. So when you see this, this is 1 cubic centimeter, this is 1 milliliter, and this is 1 gram. So if we go back and we look at the metric units, so we've got kilo, hecta, deca, bar, deci, centi, milli. So as far as the mass goes, we're here. We're at the gram. But as far as the liters go, we're there. So let me ask you something. If I'm trying to get from the milli to the gram, how many places do I have to move left? 3. So 1, 2, 3. But what happens? What you do to one, you have to do to the other. So if I move 3 places left there, what do I have to do here? 1, 2, 3. So by the time I get to the gram is running away from the milliliter, right? And it's always how many places ahead of it? 3. So what happens if I move this? 1, 2, 3. What's going to happen to that gram? It's going to run 3 more places. Anybody remember what was 3 places after K? So we have mega, giga, tera. Just throwing it at you, just curious. Okay. So it's always going to be 3 places away from the milli. So no matter how far you run, gram's going to keep running away from it. Does that make sense? Okay. All right. Density. All right. This is the most important thing that we're going to talk about today. Go ahead and write that in, and as you're writing it, we'll start talking about it. I'm going to let you absorb it for just a second. There are 3 things in chemistry that never go away. One of them is the periodic table of elements and everything that belongs in it. Number 2 is measurements and units. They'll always be there. Density is included in that. And the other one is a fun word called stoichiometry. Yeah, I know, it sounds funky. We'll get there later. Okay, just hold on. Stoichiometry, yep. And a part of the measurements and calculations that we have to do, density is going to be one of the most important parts, because the units here are going to be very, very, very valuable to us. So I teach this in a way that is almost impossible to mess up. If you mess this up, then you got a long road ahead of you. But it's going to be really nice and simple. So the definition, I'm not one of those that I want you to learn a definition, be able to regurgitate it on a test, and just walk out of here and be fine with knowing a definition. My goal is for you to be able to apply it and manipulate it. And what I mean by manipulate is if I give you any part of it, that you are able to use it in some sort of fashion other than just writing down the definition. Sorry, that was bothering me. So let's figure out a way how to use this thing that's a little bit more appropriate. First of all, what's the definition? And again, this is cool if you know it, but it's not going to help you apply it. What's the definition of density? Okay, all right, so matter. Let's start there. What is matter? This is a weird question, but what is it? Anything that takes up space that has mass. What is the basic component of matter? Now, atoms are easy. We know what atoms are. Protons, neutrons, electrons, those little things that spin around and make up everything. But I just want to make sure on the same page here, and I hope that you know this. What is a molecule? It's a group of atoms. Very good. Now, let me ask you this. Does it have to be 2 or more different atoms? Say no. No, you can have a compound or a molecule that's the same atom. It's just got to be more than one of them somehow, shape, form, fashion. Okay? So the amount of matter, or atoms or molecules, compared to the amount of space that it takes up. So let's think about it from this perspective. What if I have a beach ball that is the exact same size as a bowling ball? Is that a fair assessment? Okay. My question to you is, what do they have that's similar in terms of density? Same size. So what property, what measurement will be the same? The volume, right? The volume will be the same, correct? However, what would be different? Mass. Why is the bowling ball different in mass than the beach ball? Okay. All right, let's focus on the bowling or the beach ball. What will we say about the beach ball? It's an H word. H-O, hollow. Okay, very good. It's a hollow thing. Well, let's think about it. So if we took the densities of those two things which one would be more dense? Bowling ball. That's common sense, but let's think about it from this perspective. What if I had the same bowling ball, but I had a beach ball the size of this room? Oh, hold on. Now, do they have the same volume? Okay. Has the size change made the mass catch up? No, there's no way, right? Because it's still hollow. But are their densities now the same because of the mass change? No. Okay, they're still different. So the only way we could make same object the same density is if they have the same amount of matter and the same amount of space. So let me teach this to you in a different way, but real quick, we measure mass. Now, do me a favor. Does it have to always be grams? Could it potentially be or kilograms or milligrams or any of those other grams? Sure, it can be any of those. Okay. And then the volume unit, this is important, is that it can be either one of those. And we'll come back to that in just a second. It can be either one of them. So here's how I teach this. Now, I hope you got some space, and I think you do. There's not a whole lot of space, but conserve that space because you're going to need, I'm going to go ahead and tell you, you're going to need 3 triangles. Okay? Okay? So here's the first one. Now, here's how these triangles work. And any time we have an equation that relates variables in certain ways, we can use one of these to always make them work. So let's talk about how we actually use this thing. Do me a favor. The line that is horizontal, okay, how does horizontal lines go? They're across, right? Right? And you can, if you want to write it out to the side, or if you want to write it in it, that's fine. I'm going to write it within it. That horizontal line means to divide. Means to divide. Well, if the horizontal line is divide, what do you think up and down is? Multiply. So this is how we use this thing. There's a division and a multiplication aspect of it. Now, just a minute ago, you told me the definition of density was the amount of matter dependent upon the amount of space that it takes up, right? So here's what I want you to do. In your mind, please don't write this down. Let me think of the best way to say this before I tell you what to do. Don't write it down because I don't want you to get it wrong and have to erase all of it. In your mind, we have 3 variables. We have a D, an M, and a V, right? Density, mass, volume, D, M, and V. See if you can mentally plug in those letters of where you think they would go based on the definition of density, mass, and volume. The amount of matter dependent upon the amount of space. See if you can figure that out mentally, of where they would go, of how we would do this mathematically. Is that what anyone did? If you did, awesome. If you didn't, write that in. So now, how do we use this thing to our advantage? What we do you agree that questions always have one part of the missing variable? There's always something missing, right? You got to solve for it. So the way we use this thing is we're going to cover up the part we're trying to find. So if the question says you have a brick of styrofoam, certain mass, certain volume, what's the density? Okay, you cover up the part you need to know, and you do what's remaining. So what would I do? Mass over volume. Right? Okay. What if I wanted to know you have a cube of copper, it has a certain density and it has a certain volume. I want to know how much it weighs. I want to know the mass. What do? Density times volume. Does that make sense? This is pretty simple. Okay. The last question, what if I have a cube of lead? I know how much it weighs, and I know its density, but I want to know the volume. What do? Mass divided by density. So anytime you have two of the three, can you use this to solve it? Yes. Let me show you the math part of it that you hate. How many of you hate algebra? Let me show you the part that you hate. So if I've got density equals mass divided by volume. So if this were 8th grade algebra, they would ask you to rearrange this thing. If I wanted to isolate mass, what would I do? What's going to happen to volume over here? It's going to cancel, leaving me with what? Volume times density equals mass, right? That's kind of aggravating, isn't it? Let me show you the real fun one. Okay, what happens if we've got density equals mass divided by volume? What if I want to get volume by itself? What's the first thing I got to do? Okay, I got to get volume on both sides, right? Cancel here. Can I leave it as this? Nope. Then what do I have to do? I got to divide that. So volume is now mass divided by density. Do you agree that that's a challenging thing to do? Or what can you do? Plug it into that. It always works. So is this much easier than the math version of it? Yes, no, maybe? Okay. You have no idea what I'm fixing to write down. You have no clue what any of these things are. But we've got a formula that we're going to work with later, which is this right here. That's a Q and a CP. That's a triangle. Okay. So you have no idea what any of those variables are. But guess what I can do with this thing? I can plug it into that. I can ask you anything about it, right? If you know what these things represented. If I wanted to know M, what do? Flip that around. It's Q divided by CP times delta T, right? Okay. You said it backwards. You could, but you said divided by is divided into. Just making sure. Okay. If I need to know delta T, D, yes, delta is a triangle. You don't know what any of these variables mean, but is it still the exact same setup and concept? Okay. You cover up delta T, it's Q divided by M times CP. All right. Well, what about Q? What do you do with all those things at the bottom? Multiply them all. Okay. We'll get into this. So anytime there's an equation, and you can do this in math class. You don't have to just do it in chemistry. Anytime there's a variable that has three different things, you can plug it into a triangle, and it'll always work. Okay. Now, the one thing I want to go back and add is this part. Okay. The unit triangles. Now, I told you you're going to have to draw 3 triangles. This is where the other 2 come into play. And they're just as important. All right, and this one is going to be for solids, and this one's going to be for liquids and gases. This one, this is the measurements, and these are the units. Does that make sense? Because mass and volume are measurements, and we're going to plug units in to see this thing. So one of them is for solids, the other one's for liquids and gases. Now, do you agree that they both still have mass divided by density? Excuse me, mass divided by volume. Okay? What is our mass unit normally going to be? Grams. So let's start there. Let's put grams on top. That's got to be common sense approach. Grams are not going to change. Grams are going to be in both of them. However, the volume is going to be a little bit different. Okay? If I asked you to measure this solid cube, what do you think your volume unit for this thing would be? Fantastic. So let's write that in. So our solid would be cubic centimeters. Okay. We'll hold off on the liquid for just a second. Now here's the major question. What unit is on top? Right here. What unit is in the top of that triangle? Grams. What type of measurement is that? Now wait, mass, okay? What is in the bottom of the triangle? What unit is that? Centimeters cubed or cubic centimeters. What type of measurement is that? Volume. Are mass and volume the same types of measurements? So here's the all-important question. Will those units cancel each other out? Can you cancel grams with cubic centimeters? No. Mass and volume are two totally different things. They cannot be canceled out. So if they can't be canceled out, what is your unit for density? What? That's pressure. Where did that? That is your unit for density. Now, you told me a minute ago the definition of density is mass per volume, didn't you? In that unit, is there a mass per volume? So does the unit match the definition? Y'all alive today? I know it's Monday. It's my Monday too. I just need something. Does it make sense? If it doesn't, tell me. I don't know. I know all this. I wouldn't be here if I didn't. Explain a little better. Tell me where the misconception is. Do I need to go back to the beginning? All right, so let's look at the first triangle again. You with me? Okay. Do you understand why those letters are inside of that triangle? Okay. Density is in the bottom left and mass over volume. Okay. The definition of density is the amount of matter in an object divided by the amount of space that it takes up. So the reason I use this is I don't want to always calculate density. I'm not worried about just density. I'm wanting you to manipulate this thing as well. So what if I tell you I gave you this box? Could you measure the amount? Could you measure this box? Could you? What if I told you I knew the density of the cardboard? Okay, is that okay? Cardboard has a density, but I want to know how much that thing weighs. We cover up mass, and mathematically, how would you tell me how much that thing weighs? What would you do? Density times volume. Does that make sense? Okay, what if I wanted to know the volume of that box? I've told you this cardboard box weighs 10 grams. The density of the cardboard is a certain number. You would do what? Mass divided by density. Does that make sense? Okay, so this is what we would do mathematically. These other two triangles are the units that go along with these things. Yes, sir. Does that make more sense now? What is the top unit? What is the top measurement? Mass is, right? What's the unit for mass? Grams. That's why they're both the same. For this box, you agree it's a solid? Okay. Would you agree you would have to do it in cubic centimeters? That now makes sense. So that's why it is in the volume location. Okay. So the last part is, why did I have to include both of them in the density blank? Do grams and cubic centimeters cancel each other out? No, they're two totally different things. You can't. It's like X and Y. Can X and Y cancel? That's X and Y. Okay? You still with me? Yes, sir. We're not talking about that. We'll get to that later. Yes, no. Yes, no. Okay, sure works for me. So let's look at the other one. Now, if I handed you water and I said, here, measure this water, measure the volume of this, what unit of volume would you use for that water? So let's plug that in here. The same exact question now has to be asked. Do grams and milliliters cancel each other out? So what must the unit of density be? Grams over milliliters. Does that make more sense? If that doesn't, let's look at it one more way. Okay. Using the density triangle that we just did. If I need you to calculate mass, cover up mass, and what's left, what do you do? Density times volume. Would you agree with that? All right, so this is where it gets a little weird. Let's pretend that we're talking about, I want the mass of a solid. Using that unit triangle that you just wrote down, What is the unit in the density part of the triangle for a solid? Does that make sense? Okay. Now, what is the volume in unit for a solid? If we were in 8th grade math and I asked you what happens when we multiply those things together, what's going to happen to those units? What's going to cancel? Do you agree that technically that cubic centimeters is over 1? So that cancels and that cancels. Would you agree with that? What's left? Now, here's an easier way to look at it. What was I trying to solve for? What is the unit for mass? Does the math also prove it to be true? Yes. Does that make sense? So you can look at it from the math avenue of, all right, I plug my units in, my units cancel, I'm left with grams. Or if you know what you're solving for, should the unit always make sense at the end? And the math will always prove it. Now, some of you are math wizards and some of you aren't. So let me challenge you. Using your unit triangle, if I need volume, what do you do? Great question. Well, that's not relevant at this point. We'll say liquid. Thank you. So let's start there. So I need mass divided by density. Did you agree with that? So we're dealing for a liquid now. What is the unit for mass? Grams, doesn't matter. This is the important one. What is the unit for the liquid density? Grams over milliliters. And I know what some of you are thinking. There's a fraction and a fraction, and that is a big problem, isn't it? You don't like fractions anyways, and you put a fraction in a fraction, all hell just broke loose, right? Okay, so we got to fix this. You should know this. How do you get a fraction out of a fraction? By that R word, reciprocal. So here's what we're going to do. I'm going to change colors and make it look a little bit different. So do you agree that we've still got grams times, what is the reciprocal of G over ML? Now, we're multiplying G times ML over G. What happens? Grams cancel, leaving us with? You can look at it from the math avenue, or what was I initially solving for in this problem? Is that a volume unit? If you know that it's liquid, and you know that the liquid unit is milliliters, should you already know that that should have worked out? You absolutely could. But some people can't. Some people could not have looked at that purple over blue and known what that unit was. Some of your algebra skills aren't good enough to know that. So I'm trying to help them out. Does that make sense? Okay. Any questions on this? Absolutely. We're going to work on this stuff tomorrow. Absolutely. Absolutely. So let's look at it. We haven't seen any numbers yet, have we? Let's make it real easy. One more time. If you have to calculate the density, someone tell me what the formula for density is. Mass over volume. So let's pretend that our mass is 25 grams. You can mass that out, right? That's easy to understand. And then I tell you that it takes up 5 milliliters. Hold on. The number part of this is really easy, right? What's the density? The number. 5. I pray you know that 25 divided by 5 is 5. You don't need a calculator for that, right? Some of you do. If you did that on a test, you circled that answer and moved on to the next problem, do you get credit? You sure do not, because I don't know what 5 means. I said this earlier, it's really deep. 5 of anything is different from everything. Does that make sense? Okay, it's real deep, right? So, but my next question is, I got to have a unit on this thing. Can grams and milliliters cancel each other out? No. So do you have to put both of them? This is important. Is it grams times milliliters or grams divided by milliliters? Okay, you continue your mathematical operation here. It is grams divided by milliliters, and that would be your unit. Hold on, go ahead, Cody. Why would you put it over 1 milliliter? Because it's 5 grams per every 1 milliliter. Yes, sir. No. All right, that's a good question. And again, this is just if you're so density equals mass divided by volume, and we said it was uh, let's say 40. Let's make it easy again. Let's say 5. And we said it's 40 grams, and we said it's 5 cubic centimeters. Now, that 5 has already been cubed. Leave it alone. So you just divide the numbers as you see them. So this would be 8 grams per cubic centimeter. No, sir. No, sir. No, sir. Does that make sense? Is everyone else with me or just completely blown away? It's a great answer. Love that answer. Didn't hear a word. Hello? Okay. We'll find out tomorrow. All right. So, let's see if any more of this stuff makes sense. Go ahead and write that down. So if you're highlighting stuff, this part down here at the bottom is very important. Because making sure that you know what the density unit is going to carry you a long, long, long ways. Alright, so before we do the next thing, I'll need to ask you all a question. And it relates back to water. So if I want to know now, a minute ago you told me that density is equal to what over what? Okay, so this is something I expect you to remember. If you have 1 gram of water, how much space did it take up? 1 milliliter. Just make sense? I've told you this is something you got to have memorized. So what is the density of water? So how fancy is that? So what they then established is they said, okay, if we've got 1 gram, that's 1 milliliter. Remember that cube that I drew a while back? Okay, do I need to go back to it? This cube, right? Remember what we said about all this? We said it was 1 cubic centimeter, which is 1 milliliter, which is 1 gram. And now that we know about density, can I add something to this? What is it? Is that also true? Okay. Now, this is where it gets real funky. If I have 50 grams of water, here's the first question. How many milliliters is that? 50. Here's the important question. Think before you speak. What's the density? Is it 1 or is it 50? It's 1. So, no matter how much water you have, what's the density of water always going to be? 1. What do we call those things, that numbers that never change? Constants. The density of water is a constant. Okay? And the way we know that is density is mass divided by volume, right? Well, what's 50 grams divided by 50 milliliters? 1. 50 divided by 50 is 1. So it's never going to change. You could change it to a million divided by a million, and it's still what? 1. So the density of water is a constant. So let's go down and let's look at this. Actually, a few things. This is a list, and I like this list. You don't have to write anything down on this. But this is a list of substances and their specific densities, okay, at a specific temperature. On the left, you've got a bunch of solids, and on the right, you've got a bunch of liquids. So looking at this, you've got cork, butter, ice, sucrose. Anybody know what sucrose is? What's sucrose? Table sugar. Yep. Okay. Bone, diamond, copper, and lead. And then liquids, you've got gasoline, ethyl alcohol, kerosene, turpentine, water, seawater, milk, and mercury. Now, there's two things I want to point out. Number one, I want to compare these two things. Water versus seawater. Which one is more dense? Why do you think seawater, if I had 2 equal cups of water, why is seawater more dense than tap water? Salt, right? Does salt add mass? But is it the exact same amount of volume? Yes, that's why it's a little bit more dense. The second thing that I want to connect is this and this. Okay. What's the difference between ice and water? Now, that's a stupid question. What's the difference? One's a solid, one's a liquid. So here's the weird part. My first question to you is, what does ice do in liquid water? No, what does ice do in liquid? It floats, right? Okay. Why does ice float in terms of density? Look at your numbers. It's less. Go ahead. Question? Hold that thought. So here's the weird part. If you take a bottle of water and you put it in the freezer, what happens to the water in the bottle? Does it almost bust the bottle open? Okay, so I want you to think about this. In terms, and you got to think on the really, really, really small scale, okay? What's happening to the speed or velocity of the molecules when it gets colder? They slow down, right? So you would expect, as the molecules slow down, they would get closer together, right? But in water, when you stick that bottle in the freezer, what happens to the volume of that bottle? It expands. There's a reason for that. Actually, water is one of the weird things that actually does not condense. Most things, when they get cold, actually condense, but water is actually one of the few things that expands when it gets colder. The reason why it has to do with the molecules and their shapes and the forces between them, and we'll talk all about that later. But water, in a strange, weird, odd way, actually does opposite of what normal things do. Yes, sir. Okay, so let's talk about that. When you put a Coca-Cola in the freezer, does it sometimes bust out of the can? It has to do with the water expanding in that can. Mason, question. Yes. Yeah. In the summer, my ring fits better than it does in the winter. And plus, also has to do with water weight too.